All right, we're going to go ahead and get started. I wanted to say welcome to everybody who can join us here. This is Netflix's first AMA alongside Devnexus. This one, we're going to talk about Netflix server architecture and developer tooling with three of my esteemed colleagues. Those of you that have joined us, welcome. We are recording this and we are asking for folks to interact through the chat and then also through the video if you're interested. We're going to do about 10 minutes of slides that Ed will walk us through, and then we'll open it up to questions from everybody. So I encourage you to put your questions in the chat as the slides are going on, and we'll gather them and we'll talk through them. And we're going for about 25 to 30 minutes here. With that, I'll turn it over to Ed to kick us off.
All right, hello, Devnexus. Welcome to our Netflix AMA regarding server architecture and dev tooling. Now, at Netflix, we operate at scale by hosting our control systems in a multi-region active-active cloud deployment while serving up content via our OpenConnect CDN. In this talk, we're going to focus on the cloud deployed architecture facing our 200 million plus customers and thousands of different device types that hit our edge. We'll also do a quick walkthrough of a sample deployment, showing the automation that allows us to get new features out to the cloud in short amounts of time with high confidence. We'll then move to your questions. I'm glad to say that at today's AMA, we have Netflix representatives with experience across various parts of our ecosystem. Let's take a couple minutes to walk through the architecture and call out the Netflix folks here on the AMA to whom you may want to direct your questions. We'll start at the very edge of the edge architecture, namely our cloud gateway system. This is our front door proxy service providing traffic shaping, rate limiting, etc. It also provides or enables us to override routes for particular clients and enrich requests from client devices in a targeted manner. Haley Tucker is the AMA expert here today to represent how we leverage the cloud gateway features to provide infrastructure experimentation tooling for validating and delivering software at Netflix. Now, after passing through the cloud gateway, client traffic is able to hit client-specific server-side code in our BFF tier. Now, it's not best friends forever for the clients, rather it's our backends for front-end system. The BFF tier uses server-side JavaScript to define customized behavior facing different client types. Code in the BFF tier runs on our Node-Core JavaScript platform and is deployed in containers using our Titus container management system. Now, the JavaScript code in the BFFs invokes Java implemented customer journey APIs that are served up from an API aggregation layer that in turn interacts with hundreds of different services in the domain services tier. Jennifer Shin is our API specialist on this AMA and can answer any questions you have around the architecture of this layer. Now, moving the rest of the way to the right, we encounter the domain services and domain data that provide core business logic and persistence. My own team, Playback Systems, operates here in a sea of Java microservices that interact with each other via remote procedure calls. Domain data services in this tier provide persistence where needed in the distributed system. Now, let's move from architecture to developer tooling. To do that, we're going to go through kind of a sample code deploy. We're going to do CI, CD, our prod deployment, and then we're going to monitor what we've put out to prod. So what you're seeing here is our Spinnaker continuous integration, continuous delivery user interface. You'll also see it on several slides to come. This is the Spinnaker icon. And notably, it's also an open source project. You can check it out at spinnaker.io. All right, so after say we've made a code change and our pull request has landed. This is our mainline Spinnaker build, or Spinnaker pipeline, excuse me, where we will do standard tests, unit tests, smoke tests in that first phase. Then we'll proceed to what's called baking. Now, because our systems deploy in multiple regions, and we generally like to auto-scale to make efficient use of resources, we prefer to deploy immutable server images. So let's take a quick closer look at the bake phase. Here we would have baking for Amazon Web Services. So we have an artifact, a software artifact, a Tomcat War or Spring Boot jar. We're going to put it in a Debian file, and we're then going to bake it into an Amazon machine image. And then once deployed in the Spinnaker UI, it looks like this. You can see, if you look closely, there's a little green box on these auto-scaling groups. You'll also note that they are in several different regions. As I mentioned earlier, we have a multi-region deploy, and each of these regions can scale independently to match load, which is inevitably different in different parts of the world. Now, when it comes to Titus, Netflix's container management system, we start out with similar artifacts, but this time we're actually putting together a Docker container, uploading the Docker container to a registry, and deploying that as well to the cloud. Now, these green boxes look similar, but instead of discrete EC2 instances, or Elastic Cloud instances in AWS, these are containers probably running on a much larger system, but they each appear as their own little green box. And you can see that we have our Titus robot instead of the AWS box on each cluster. All right, so now that we have an image, let's keep making our way out to production. We've already done some early unit and smoke tests as part of the initial CI/CD build, but now our code is running in prod for the first time. So we're going to use a canary to deploy a small population of the new server alongside a similarly sized deployment of the prior server and do some automatic metric comparisons. You can see here also that we're running canaries in multiple regions, and we're even actually staggering these canaries a little bit. This is to, for one thing, lint out any region-specific problems there may be, and also to avoid deploying something new everywhere at once and possibly causing a production incident globally. Here's how a canary analysis looks in the reporting. We have various different criteria against which we want to evaluate the new server that's going out. So we've got CPU load, failures, TCP connection related things, timings, like P50, P90, P99 are likely related to timeouts or handling times for requests. And here you see baseline is blue, red is canary. And I'm glad to say usually we do not have to dig too deep on these as humans because the machines are tracking correlation, usually using an Eli-Whitney classifier, and being able to determine whether we're close enough to what we had before. Let's go the rest of the way to production. And note that because things have been green so far, each step has proceeded automatically. There's been no manual intervention required. And that's important. I mentioned that in the domain data and services tier, we have hundreds of services. My own team of about 6 developers has 20 applications that we deploy in a microservices environment. So it is important to have automation just continually putting out these servers, usually every day, sometimes twice a week, and even also updating dependencies automatically. So before proceeding to full deploy, note that, that we have a failover check. This also relates to our multi-region deployment stance. And if you attempt to deploy to a region when traffic has been evacuated from that region using that cloud gateway I talked about, we're able to actually shift traffic around the world fairly readily. If you do deploy to a very quiet region, you end up with potentially very skewed metrics. So one thing that just from experience, we've seen the need to introduce in our pipelines is a failover check. Like, is this, are we really active in a given region before we try to deploy to it? The automation can check for a failover if one's happening, then it can actually just wait until traffic is restored to a given region, then proceed with further rollout. So here we go. We're actually rolling all the way out to prod. I say this is a rolling deployment because while it is possible to bring up a new set of servers and just take the prior servers out of our discovery system so they're no longer seen by callers, here you can see that we are gradually and incrementally rolling out more and more. And this is also being done automatically. It's a rolling deploy. In this case, it was a nice smooth deployment where the prior server deployment was taking plenty of requests and there's basically no change. And the clients are now hitting a new server as we come out of the rolling deploy. Here's how we look once we're up. All right, so I want to go briefly over some monitoring techniques that we have. I'm going to speed up a bit here, but please do keep your questions in mind and we will be answering them in the AMA section. We use time series monitoring with the Atlas open source software, where we are able to track specific metrics over time. These metrics are used quite a bit in our canary analysis. We also have, for human use, Elasticsearch. And this allows us to capture things that might have what we call much higher cardinality. For example, in this dashboard, you're seeing that we're able to surface which particular viewables. Out of the thousands of things that you can watch on Netflix, there might be just a few viewables in a particular experience. This lets you see exactly what those were. You would not necessarily want an atlas metric showing individual title numbers, because that would be a high cardinality condition that might be less efficient. And finally, stream processing. Mantis, definitely check out Mantis. It's a stream processing engine that gives you real-time access to tons of information. This allows you to not have to necessarily know ahead of time what you want to be tracking. Rather, you can dip into the stream of activity on a given service and be able to do some very cool metrics, or actually just intercept, even sometimes replay traffic if you want to. So Mantis, check it out. Finally, I want to get into one more very important thing, the chaos automation platform. Haley here could tell you a lot more about it. It's made possible largely by the cloud gateway enriching the data as it comes into our systems. And the critical thing to call out here is something called sticky canary. What I showed earlier was a standard canary. We put up a small server deployment, we got a certain percentage of traffic, but arbitrary traffic. With a sticky canary, especially for cases where things you've changed on the server could be impacting the client and only the client can tell you that there was a problem, the sticky canary is huge, because it's allowing you to pick particular clients' traffic, always send them to the same mid-tier service. And that'll lint out problems way quicker. And it'll also help you to get a much better signal for, say, a particular client that has like 0.3% of the traffic overall. If you're pretty sure you're going to affect it, you could set up a sticky canary to say, I want to get a disproportionate amount of that client's traffic and do my canary against that. So that's a pretty powerful thing that the cloud gateway is able to enable. We have other types of CHAP operations as well. Squeeze testing can be facilitated by sending more traffic at a particular server. Chaos and unscoped chaos, we could talk more about. This is classic Netflix. You know, we used to call it the simian army, but we're still able to inject latencies, kill services on demand behind the scenes, and try to intentionally destabilize things while keeping it controlled, hence the automation platform. I'm going to actually keep moving because I do need to respect time here and get to the AMA portion. This is just showing that when we are doing a sticky canary, we can correlate not just server-side behavior, but also client-side behavior, because we were able at the cloud gateway to designate certain clients as interesting to our test. All right, let's proceed to the AMA. I'm going to step back a bit. I'm sure you've got lots of questions already. And Philip, would you like to facilitate?
Absolutely, yeah. I love the questions so far, so keep adding them as they come to mind. I'm gonna do a little bit of grouping so that we can answer a couple of questions at once. So there's a variety of questions from, I believe Thomas had asked about this, and a couple other people here. And so I'm gonna group these together into the developer experience, developer platform. Haley, do you mind talking us through what does it look like for, when you're actually changing code, what platform you're developing on, what do you do local versus in the cloud? And then we'll go to maybe Jennifer for continuation on that.
Sure. So I think I saw one of the questions was about like workstations, and like we allow people to select their workstations. I would say it's primarily Mac users, but there are the occasional Linux folks. But we like to keep that open. As far as like tech stack, we're primarily Java, but there is also JavaScript, there's Ruby, there's Go, depending on different parts of the ecosystem and what makes sense for the business and your use cases. As far as like the balance between developing locally and then moving that out into the environment, I would say it probably varies per team, but we're able to do most of our development locally and unit testing. And then you would be able to use Spinnaker to deploy a change out and do integration testing, sticky canaries with that build, various things like that. Jennifer or Ed, do you have anything to add there?
Specific to the way that we can kind of do our local testing, I think I had seen a question about how much you can kind of reproduce the remote situation locally. So we have what Ed was talking about in our BFF layer. We're deploying server-side JavaScript code into Titus containers. You can actually run those locally as well, and so reproduce that sort of entire like stack, I guess, locally. Also on the server side, we are running Java services, and those are also completely runnable locally.
And Jennifer, you want to speak to that a little bit more? There's a question around tech stack, and there's a lot of Java. Talk us through a little bit about the suite of technologies we're using in the back end.
Yeah, so yeah, I think somebody asked why we chose Java for our kind of backend language. And at Netflix, we have this idea of a paved path. And so our platform engineering team is going to make basically this paved path, if you choose to take it, very, very easy for you to kind of spin up a brand new project up from the ground. So I can just go into my terminal, say, execute a command like our executable is called Newt, N-E-W-T. I can say Newt, new Java project or something. It'll just spin up a brand new Spring Boot application that has kind of like built-in metrics. It has support for these canaries, these pipelines. All of this tooling basically comes for free if you choose to use this Java paved path. And so, we just kind of chose Java to standardize on this paved path. You can choose to stray from it, but obviously it comes with a lot of hurt. So most people choose to stay on the Java side.
Great. Let's go back to Haley. There's a question around, and Jennifer, you spoke to a little bit about testing locally. Haley, talk us through a little bit about how we approach automation testing, chaos testing. Expand a bit on what Ed had showed there.
Sure. Yeah, so the chaos platform is sort of built up on layers. There's one layer that basically is integrated into all of our Java libraries, and that is what we call FIT, or failure injection testing. And so this allows you to, in a very targeted manner, inject failure or inject latency into a specific cache call or a specific IPC call, for example. So this lives in our stack. All of the services have this library, and it allows you to inject failures. You can also use it for unit testing or integration testing as well. Layering on top of that, we basically, at the Zool layer, or that cloud gateway layer, we augment the data that we pass through on requests. So we can say, okay, so for this particular request, fail this interaction down the stack. And we do this with a header, and that header gets passed all the way through the stack. And at some point in the stack, that IPC call or that cache call will say, oh, I'm supposed to fail this, so let me do that. And what that allows us to do by having a single point of allocating users and then passing that through the stack, we're able to tightly control who's getting that experience and for how long. And so then that sets you up for being able to do experiments. So I can take a baseline population of users and a canary population of users, inject failure or latency into that population and see how far it diverges from the baseline. So being able to do that allocation at the gateway layer allows us to pull metrics and insights off. And that is really what drives the automation aspect, because we can monitor and we can shut things down very quickly if things are going sideways.
And Haley, follow-up question on that, because there's some questions around it. So does that apply to functional changes? What about libraries as you're integrating new libraries? How does that fit into that testing and rollout strategy?
Yeah, so I would say you have the option. It depends on how broad you want your test to be. So if I have a new library that I'm pulling into a specific service, I can take the new AMI for that service, deploy that out into the Canary cluster, and inject failure or latency into that and see how the behavior changes. So in that case, you're testing that library along with the failure injection. If you really want the test to be broadly executed, then unfortunately we don't have a way right now to push a library out to like an entire fleet of services and run that test. You'd have to wait till it rolls out, probably put it behind a feature flag or something if you wanted to protect it, and then be able to test it from there. Ed, did you have something you wanted to add there?
Very briefly, yes. Just that I wanted to point out, someone had asked about our GitOps strategy in the chat. Well, we're using Git for sure. And we have Stash for pull requests. But I wanted to point out that our pull requests can also be automated. So if you're interested not just in a library that you've changed for your own service, but maybe you're just facing the world, right? And you have a few dependencies on other team services, you don't always want to know all the context on what they've been changing. What you do want to do is stay current, right? Lest they start killing off things behind some old library that you depend on. So we do have automated pull request generation that can pick up the latest dependencies, automatically put up its own pull request, run through the whole pipeline set that I showed in my talk. And sometimes you just get your dependencies updated for free, which is great. So that's one way where we're not leaning on the Chaos platform, but rather just the DevOps cycle to keep our dependencies fresh.
That's great there. And yeah, keep the questions coming. Just so folks know, we'll go for another 10 minutes or so. We may not be able to get to all the questions, but we do have people in the virtual booth all day, and we'll make sure we bring some of these questions over there to for those that we didn't get to. Jennifer, Ed, do you want to talk about the DevOps culture that came up earlier? There's a couple questions in that space. Go for Jennifer.
DevOps culture, gosh. So we have some things that are kind of taken care of by the runtime, kind of the platform engineering, and kind of like the way that I mentioned, the platform, the paved path, metrics, all of these things kind of come for free. Even the dependency update cycle, these things like our dependency updates, I think run every 3 hours or something like that. And so there are things that just kind of work automatically. That said, I mean, managing dependency update cycles, sometimes it can be a full-time job because obviously if you're pulling in, I think our platform pulls in like 10,000 dependencies or something. And so there's bound to be breakages quite often. The way that our team does things, and because Netflix has this whole freedom and responsibility culture, every team might do things differently. But typically we have an on-call engineer who's on call for 1 week. And so we do like a rotating shift. That person is typically responsible for responding to alerts, responding to pages, taking a look to see if dependency update pipelines are broken, going in and trying to see what the conflicts might be. But every team might be doing things differently.
Thank you, Jennifer. And we'll go to some more questions. Just so folks know, there's good questions around GraphQL. Jennifer's an expert in there, but I think we'll do those in the booth after, if that's okay. I'll share some links that have some more info there. Let's go to the question a little bit on gRPC and database and caching strategy. There's a few recent questions. Ed, do you want to talk to that? A little clarification asked about the RPC one, and then anybody wants to speak to database and caching.
I was just typing a response regarding whether we are able to freeze dependencies. I believe it was from Ralph McNeil on the chat. And yes, we are, because we used Nebula, which is the Netflix build language, on top of Gradle to be able to specify dependency locks. It's a fairly simple plugin you can apply in your Gradle settings that allow you to do Gradle W, generate lock, save lock, and you'll be able to save locks as is, or even roll them back in the source. But what was your other question there, Philip? Was it about interprocess communication?
Yeah, because you mentioned IPC for a lot of the service communication. You want to expand just a little bit on that?
And I'm so glad you mentioned that, because I was intentionally being a little broad there, because we do have at least 2 major types of IPC. One of them is our older style Netflix web services using REST, right? With separate bulk heading using what we call Hystrix, another open source project, to help with avoiding certain services, overwhelming other services. However, more recently, and again, to Jennifer's point about the paved road, there's a strong move toward gRPC, where we're, instead of explicit bulk heading thresholds, we're really more leaning on concurrency as a metric for whether we have a good connection or not. And a lot of our systems are moving now to gRPC and really benefiting from it. Fewer bytes on the wire, extremely efficient IPC, to the extent that that has been a great strategy for getting away from some of our fat jar dependencies. So rather than having a lot of libraries, we're now able to simply invoke other services with a couple milliseconds, right? Per call, not too much of a hit, but the benefit being that the services are able to evolve separately while adhering to contracts between them.
Great, Ed. We'll go for 2 or 3 more questions in here, and then, like you mentioned, we'll take the rest in the virtual booth. Jennifer, can you speak to the BFF a bit? There's a question around, is there a framework around it? Talk a little bit about that, please.
Yeah, so I think Ed had pointed out that BFFs are kind of device specific. So we have basically generally like 4 major devices, right? TV, iOS, Android, and web. Sorry, I don't know why that slipped my mind. Each of these are now deploying containers, Titus containers to the cloud, and they are responsible for doing kind of individual device specific transformations of the APIs that our team basically provides. Like I said, these are Titus containers, they're running JavaScript. The way that we interact with, so my team is the API team, kind of in this green box, it says Customer Journeys API. The way that we interact with these BFF layers is that we provide this JavaScript library that is a way of invoking these APIs. Basically, our team provides a graph API similar to GraphQL, but it's called Falcor. It was developed in-house. We created kind of our own custom JavaScript library for it to be able to invoke things, the APIs kind of more easily, I guess, as opposed to in the Falcorisms, it's building up a query can be a little bit cumbersome. So that's how we interact with them. I'm sorry, I'm not sure if that answered the question, but feel free to ask more.
I think that did, Jennifer. And for a lot of these questions, I have links that I will share that we can put in the booth. So those of you that want more information, you can navigate to those links and see that information. Haley, did you want to talk a little bit about the database and caching strategy? There's a question on that earlier.
Just that we use them? No. so we use a combination, depending on the use case. We do have Cassandra, we have EV Cache, which is Memcache, Netflix's Memcache version. There's also Redis. There's a variety of data stores, databases and caches. They are better integrated, I would say, into our gRPC stack. So like part of the interceptors that we've built around gRPC has allowed you, at least some of that, the caching, to like have that directly in your IPC flows. We do have a central team called CDE that manages the large data stores for us. So they handle like the initial sizing, helping us scale up when we need to, like migration strategies there. So kind of a team effort. Any other thoughts, Jennifer, Ed, on that one?
Yeah, I would just mention that a big reason we use Cassandra is that, of course, it's NoSQL, also has fairly first-class global replication capability, where we've got our quorums local to each region, but we can also synchronize fairly readily among the regions, such that when we do need to do a traffic failover, where you have the data there that was originally written in a different region, it's great to have a data store that's optimized for writes and has kind of first-class global replication capability. And one other quick platform I'd give a plug for is called Dynamite, DYNOMITE. It's more of an all memory, I think probably Redis-based distributed cache, but also with the global replication capability and an emphasis on key value storage and retrieval.
Yeah, and I will add that on the API layer, because Netflix requests are so heavily personalized, this customer journeys API where we aggregate all of the kind of the data is typically not cached. So we really don't hold any state on the API layer. It's mainly the domain services that are responsible for that.
Excellent. Well, we're coming to time here. I wanted to encourage folks continue the questions in the virtual booth. We'll share some of the links like I mentioned there, and feedback also welcome. There's already some good feedback in the chat on ways we can improve this. We'll aim to have this recording available for a couple days this week so that you can share with your colleagues and friends who couldn't make it. Ed, Haley, Jennifer, final word, anything you want to share or what you enjoy about Netflix engineering?
Thanks so much
Jennifer
for coming.
First.
Okay, that worked out. Yeah, thanks so much for coming. This was a lot of fun. One thing that I really, really love about Netflix is just the freedom and responsibility culture. I get to work on, I can't think of 2 consecutive quarters where I was working on the same thing. So it's always like keeping me on my toes in the best way possible.
Really quick, I've also appreciated the DevOps culture. When I started at Netflix, we had one mega service I was usually working on, deployed by a separate team. Now we've got 6 services run by a small team of about 6 developers, and we're deploying our own stuff every day. So I get a super kick out of that. And I also enjoy the freedom and responsibility culture. Haley?
Yeah, I would say the opportunity for learning is huge. And like from day one to like I've been here 7 years now, like I always feel like I'm learning something and growing and that I don't know what I'm doing. And it's great. It's awesome. And like we're always pushing to be better. And so like the tooling and the infrastructure as well is always evolving. So like I love that about it.
Thanks, everybody. It was great to have you engage and ask us questions. We'll see you online. Stay safe and take care.